Hi you guys. So before we get started with anything for Algebra 2 Trig, we're going to look at some algebra review first. So this lesson is going to be on equations, expressions, and determining expressions. And here are our objectives for the unit. Okay. So what do we know about equations and expressions? So let's differentiate between the two first. An equation has solutions. An expression has instances. Okay. Notice that I put the parentheses here for the S. That's because it can have one solution or more than one solution. So we're going to talk about that. We're also going to talk about what instances means. An equation and an expression both have variables, so that's the same for both of them. An equation has an equal sign, an expression has no equal sign. And for an equation, the directions are to solve, and for an expression, the directions are to simplify. We can't solve something without an equal sign, right? So we're just going to simplify and collect like terms. So let's take a look. These are just some examples. We're not going to solve these specifically, but these are some examples of equations. It has each of these have an equal sign. Here's some of an expression. They have no equal sign. And we're going to talk about instances now. What does this mean that an expression has instances? So, also an equation is a statement and an expression is a fragment. Okay, so let's take a look at, and like I said, an expression has instances. So take a look at this expression, 7a plus 6. We're going to look at two different instances when we would evaluate when a is a different number. So for example, the number 1 says evaluate at a equals 3. That's one instance. So I'm going to plug 3 into here. 7 times 3 is 21, and 21 plus 6 is 27. Okay. What about when a equals negative 4? Negative 4 we're going to plug in here. 7 times negative 4 is negative 28, and negative 28 plus 6 is negative 22. So those are two different instances for the same expression. And they're literally infinite a number of instances, right? We could put in negative 100. We could put in 555. Whatever you want, you can make a equal, right? And you're going to get a different answer, right? So we have different instances here. So the instruction or scenario dictate the outcome. So it just depends on what you plug in for A, and it's gonna be a different outcome. An equation has solutions. So an expression has instances, an equation has solutions. So we're gonna get an answer for all of these, right? Because it has an equal sign. So the first one, we're gonna add 9 to both sides. Negative 17 plus 9 is negative 8. And then we're gonna cancel out here, bring down the 2x, divide by 2. Negative 8 divided by 2 is negative 4. So our answer, we have one solution. It's x equals negative 4. For number 2, we're going to distribute that 4. So it's going to be 4 times 2 is 8x. 4 times negative 3 is negative 12. Bring this down. We're going to subtract 8x from both sides. This cancels out and this cancels out, right? Because 8x minus 8x is 0 and 8x minus 8x is 0. So we're left with negative 12 equals 4. Now that is no solution because when you have the left-hand side does not equal the right-hand side and both of the variables cancel, it's no solution. Okay, now for number 3, if we distribute that negative, now notice we're not distributing the 5, we don't carry that over the negative, we distribute that negative 1, it's a negative 1. So we're changing the signs, so it's negative 2x minus 9, everything else stays the same. We're going to combine like terms, so that's 3x minus 9, 3x minus 9. Now we're going to subtract 3x from both sides. The 3x's cancel, and we're left with negative 9 equals negative 9. Now, if both numbers on either side of the equal sign equal each other, if they're the same, then your answer is infinite solutions. Okay? So, equations can have variables that represent one solution, no solution, or infinite solutions. Okay, and we just saw an example for each of those. Variables are letters or symbols used to represent a value for a solution or instance. So these are just some examples of letters and symbols that we could use to solve or for instances. So for example, like we could say 7y plus 6 instead of 7a plus 6, right? We're still going to get the same answer. We're just changing the letter or the symbol. Okay. Now, English to math. We usually do this in class, but obviously since we're not in class, I'm just going to give you these answers. These are just some examples of, for example, add. You could say add is sum, the sum of, right, plus more than, greater than, in addition, increased. Here's some words for subtraction, multiplication, and division. So take a look at these. Make sure you know what these all represent. And if you have questions, let me know when we meet in class. Here's some notes though. Be careful with more than versus is more than. More than is up here, right? This is more than. More than is addition. It's under the addition part, right? Is more than is an inequality. That is makes all the difference. So more than means add. Is more than means it's going to be an inequality, okay? Same thing for less than versus is less than. Less than is subtraction. See, less than subtraction. Is less than is an inequality. So notice that there. Be careful there. Okay, less than flips the order of subtraction. And we're going to talk about that on the next page. But don't forget, less than flips the order of subtraction. Okay? And then quantity of is grouping, right? So we're also going to talk about that. Grouping. So just put parentheses, like the quantity of 2x minus 5. That means you're going to put parentheses around 2x minus 5. So quantity of is grouping. You always put parentheses when you see that of. Like the sum of, the difference of any of those things, when you see of next to it, you're going to group in parentheses, okay? All right, let's translate each of these phrases into a math statement. So a number divided by 3 plus another number. That's how that looks. A number divided by 3. So the number, you can make any of these different, by the way. You don't have to use x and a, obviously. A number divided by 3, so x divided by 3, plus another number. The only thing you have to remember here is that a and x cannot be the same because it says another number. So just make sure these two are different, okay? 4 times the number minus 9, so 4a minus 9, or 4y minus 9, it doesn't matter. 5 less than twice the number. Now here's where we switch. Remember on the last page I said less than means you have to flip it. So instead of 5 minus 2a, or 2x, I'm sorry, I guess we used x. So instead of 5 minus 2x, it's going to be twice, whatever's after less than, which is twice a number, that goes first. And then the 5 comes after, and you put a subtraction sign in between. So that less than flips it, okay? Now here, the sum of a square of a number. So let's kind of break this up. A square of a number times 3. Now this and means plus, because how do we know that means plus? Because it says the sum of, right? So we know that the sum of means plus, so we know that and is going to mean you're going to add half the same number. Okay, a square of a number times 3. Well, a square of a number is something like x squared, right? That's a square of a number. We don't know what the number is. We could have said a squared. Times 3, we're going to put the 3 in front. And we know is plus because this said sum of. If that said difference of, we would put this and would be subtraction. So this part at the front tells you what this and is going to be, okay? So plus half the same number. Okay, so half the same number. See, they said same number, so we're still going to use x. So half the same number. So I'm going to, half the same number looks like this, right? You could also have this look like this, 1/2 x. That's the same thing. Half the same number, 1/2 x is the same as x over 2. Okay, so I'm going to make this a little neater, and I'm going to backspace over here and do this. I just wanted to kind of break this one down for you. Okay, so 3x squared plus x over 2. X over 2 is the same thing as 1/2 x. Okay, let's look at a couple word problems. Your cell phone plan allows you 750 minutes a month of call time. If you spend half an hour on the phone each day, write an expression that describes this situation. So the expression T equals days. Okay, so T is days. So your cell phone plan, the total amount is 750. You only have 750 minutes a month of call time. And you spend, which means minus, half an hour on the phone each day. So 30 minutes, 750 total minutes, minus 30 minutes, depending on how many days you talk, right? So let's look at these 3 instances. Determine the number of minutes left after 10 days. So we're going to plug 10 into here. So 750 minus 30 times 10 30 times 10 is 300. So 750 minus 300, which is 450. Okay, after 16 days, same thing. You're going to plug in 16 to t. 750 minus 480 is 270. Okay, so that's the total number of minutes left after 16 days. She still has, or you I guess it's your cell phone plan, you still have 270 minutes. Okay, is this plan sustainable as is? Now, let's just check in February, for example. There's 28 days, right? So we have 750 minutes, and we're going to talk for 30 minutes a day. It's day 28, and we have to figure out how many minutes we have left. So 30 times 28 is 840. Well, 750 minus 840 is negative 90. There's an overage charge, so it's not sustainable, right? Because you have to have this, you're not going to have enough minutes. You have negative 90 minutes now, so you've already went over, so it's not sustainable. Okay. So there is only one freshman in class. There are 6 sophomores and 11 juniors. 1/3 of the class are seniors. How many seniors are in class? So there's 1 freshman in class, 6 sophomores, and 11 juniors. 1/3 of the class are seniors. We have to figure, so first of all, how many non-seniors do we have? We have 1 freshman, 6 sophomores, and 11 juniors. We have 18 total non-seniors. All these are not seniors, right? So we have 18 non-seniors. 2/3 of the class are non-seniors. That makes sense because 1/3 of the class is seniors, so 2/3 of the class are not seniors. So we're going to put this information together to write out an equation. If 2/3 of the class, I just decided to make this C for class, so 2/3 of the class equals 18 are non-seniors, right? Let's solve. So 2/3 C equals 18. Now, when we have a fraction next to a variable, we multiply by the reciprocal and we cancel. So that's going to cancel, that's going to cancel. We have C equals, now 18 times 3/2 is 27. We can put that 18 over 1 and multiply across, right? Cross cancel and multiply across. So 27. Okay, that means 27, there's 27 people in the class. The class has 27 students. And we know that there are 18 non-seniors. So 27 total students minus 18 students that are not seniors are going to give us the number of seniors, which is 9. Okay. 2 friends bike starting from the same position in opposite directions. One friend bikes 12. Oh my gosh, let me start over. One friend bikes 3 times faster than the other. After 3 hours, they are 120 miles apart. How fast was each friend biking? Okay, so they start from the same position. And they're going to turn around in opposite directions, right? So it says one friend bikes 3 times faster than the other. Okay, let's call the other X, right? So one friend, they both start here and they go in the opposite direction, X. The other friend bikes 3 times faster. So one friend's going to the right, X, and then the other friend's going 3X because they're 3 times faster. Now it says after 3 hours. This is 1 hour. After 1 hour, they're both this far apart. After 3 hours, we have to, they're going to be 120 miles apart, right? After 3 hours, they're 120 miles apart. How fast was each friend biking? So we're going to combine, so we know that 3x, there's 3 x's, and we're going to add 3 x's, right? And that's going to equal the total number of miles that they are apart. So we're trying to figure out how fast they were biking. So equals 120. Okay, so this is called the segment addition rule, where we have a piece plus another piece equals the whole thing, right? So we have this friend that rode 3 times faster, this friend that was just riding X miles an hour, right? And they rode a total of 120 miles. So 9x plus 3x is 120. And then 12x equals 120. We're going to divide by 12, so x is 10. So one guy was riding, the slower guy was riding 10, but if we plug this 10 back in here, the guy that was riding faster, the 3x, the rate of the faster guy, is 30. Okay, so the slower friend rides 10 miles an hour and the faster friend rode 30 miles an hour.